Today we're talking about AI and explainability. And as there is no understanding of AI, there's no use of AI. If we don't have an explainable AI, it's hard to trust the AI. Michelle, we already discussed about trust and how AI can be trustable algorithms. Today, we're going to discuss a little bit more about, we're going to unpack the black box, right? Because sometimes the AI could come up with a decision, could come up with an answer, but we don't really know why, okay? And they did some research on, the aim of explainable AI. So would you mind tell us a little bit more about this? So what is the goal here? So apart from the obvious the obvious idea, which is it is explainable, therefore it is trustable. What else can we say there?
Okay, so as you mentioned there's two ways of machine learning. There is like the white box. So these are like the ML models that provide results and that it's really understandable for expert domains, right? So it's not a black box. And then the second type is black box. So it's extremely hard to explain and can actually hardly be understood even by the domain experts. So this, you can imagine, is the kind of thing where you just put the information, right? And it learns on its own. It's kind of how chess was done from the grandmaster, we talked about it in a previous episode, right? So that one, it's really hard to track, right? Because it's learning on, and it's learning true failing on its own. So that's the black box, right? Now, why is this important? It's important because the first type, the white box, it's easier to explain. And because it's easier to explain, you would think that we would prefer it. But the difference is that the black box performs much, much better. And so this is why now we have this problem of like, okay, if the black box performs better and we really want to use that for most of our things, then we really need to figure out this problem of explainability with regards to this type of AI. So this is kind of the aim of the explainable AI, to really like look at how the black box performs and really to try and unpack it, right? And to see, can we still track how it was built and like how this machine is learning from itself, to be able to, again, as we have talked previously, to build that kind of trust, because it's important for accountability, right? Because if the machine is learning on its own through its own like little information, right? And then you send someone, then it makes a mistake, where does the accountability lie, right? Because then somebody say, well, I didn't teach it, it taught itself. But if that's the response for everything that goes wrong, then people won't be able to build that kind of trust with regards to AI. So if that makes sense, that's the reason why it's really important, and kind of the aim of why we really want to make these kind of like black box learnings more explainable.
And I think if I can comment on that, I think that there are two main goals. One is forensic. Okay, so there is a autonomous vehicle. The autonomous vehicle crashed. I want to understand why it crashed. Okay, so exactly. The second one is more about real-time trust and real-time use of the machine. Let's say that I'm a CEO and I get a forecaster for sales. I need to take decisions. I need to understand why that forecast was predicted, and so that I can take my decision in an informed solution. And I think as a machine learning scientist and practitioner, we didn't want to create black box machine learning. It's not that we wanted to hide their functioning and conceal their reasoning. It's just hard. Okay, it's hard because sometimes we don't even know. Like with deep learning models, we don't even know exactly how the machine came to that conclusion. But this is an interesting and very active field of research that essentially enables users of AI to add an extra layer of explainability to the output of machine learning models. In forecasting, there is a very popular tool. Actually, it's data science and forecasting in general are it's a little bit easier to explain in that domain. There is a wonderful tool which is called SHAP features, and for the techies that are listening, if you don't know this tool and library, you should really take note. it enables, in a nutshell, it enables you to give a prediction or give a classification score or give an answer, and then expose to your users what are the 3 or 4 or 5 or 10 features that created that answer or that created that prediction. For instance, if we were talking about sales prediction, the variables that let's say correlate more strongly with that prediction would be also presented to the user. For instance, the CEO would get a prediction of strong growth, and the strong growth prediction will come with with variables like in the past quarter the prediction was very strong in Australia, or the level of the price of primary goods are down, therefore our growth estimated is very high. So this kind of very tangible outputs really flesh out the single output of the AI, and makes the life of the people that take decision on the top of AI much easier. Okay, and it's much easier because it's explained. We're way out of time, Michelle. If you don't have any further remarks, we should probably wrap up the episode here. Anything else you want to add?
Nope, that's it. Although I have to say, if you consider human beings and the way that sometimes we adhere to people who are really talented in certain domains, quite often we don't ask how they are this talented. How is it that you sing this well? How? We just accept it as a fact. And I like that, at least with technology and with AI, we're holding it to a much higher standard, and we're really trying to figure out ways of explaining how the results come about. So yeah, the research must be really interesting, and I look forward to seeing all of it.
Yeah, you're that right. And thanks very much, Michelle.